So today we're going to be talking about some decimals. That's basically our next or the second. So after the fractions, we spent the last couple of classes on the fractions. Today we're going to be talking about decimals, and also we're going to see all the operations with decimals. It's like a review. So basically, we're just still reviewing for this class all the operations, adding, multiplying, and so on. I'm also going to talk a little bit about percents and their relation to decimals. Let's first start with first part here. Let's define decimals and what they're made of. So basically, a decimal number has a decimal point. So a decimal number, for example, 2573. There is a decimal point, and there is some other numbers, for example, 8, 4, 6, and for example, 1. So this decimal number is made of two parts. We call this the whole part, the whole number, basically. This part is the decimal part, comes after the decimal point. So this is what we're going to be focusing on today. We'll focus more on this part. But we can briefly talk about this part here. So that's the whole part. Again, we have the ones here. Of course, you have the tens. Then you have the hundreds. So these are basically, this is the whole part of the numbers. And of course, the thousands here. Okay, no big deal here. We know this. So this is what's more important today. So the very first digit hit after the decimal, we call that the tenths. Okay, not the tenth. The tens is here, is the second number of the whole numbers, but here we have the tenths. Then after the tenths, we have the hundreds. The hundredths. Again, not the hundreds, the hundredths with a th. And then we have the thousands. And so on. What comes after the thousands, everybody? The tenths, hundreds, thousands. What would we call this?
10,000.
Exactly. The 10,000s. The thousands, also the THS. So this is basically what we're going to be discussing more. We're going to talk about each one of these and how to name numbers and how to turn them into decimals and so on. So when we say, we start with the first one of them here, the tenths. So when you say, for example, 0.1, so this is a whole part. There's nothing here but 0. This is a decimal part. So the very first one is the tenth. So we can say this is 1/10. This is 1/10, which means 1 out of 10. Okay, 1 out of 10, just like we did with the fractions. So we divide something into 10 equal pieces and you take 1. So we call that 1/10. What about, so we have 1 in the tenths, we call it 1/10. What about this decimal? How do we say it?
3/10.
3/10.
3/10. That's right. We have 3 in the tenths, not the hundreds, not the thousands. You have 3 here in the tenths, so 3/10. What's 3/10 as a fraction?
3 over 10.
1
over 10.
3 over 10.
That's right, 3 out of 10. So that's the meaning of 1/10. When you say 1/10, it doesn't mean 1/10. It's not 10. It's not 10, 20, 30. It's 1/10, meaning 1 out of 10, 3 out of 10, and so on. What about this one? What is it? 0.01.
100. I mean, 1 over 100.
1 over 100.
As a fraction, yeah, it would be 1 over 100. And how do you
Yeah.
say it? How do you
One-
say it?
But the
1 in 100.
That's right, 1/100th. Okay, 1/100th, meaning 1 out of 100. And you may also have something like this. Let's say maybe 0, and then some digits. So how do we say this number first? And then based on the way we say it, it gives us an idea of what the fraction is going to look like. So what is that in decimal form?
2,500.
100.
Not 2,500. What is the highest? What
200.
is-
A
what is-
thousand.
Oh,
Over
25,000.
Exactly. So this is the thousand. We have the tenths, hundreds,
Right.
and the thousands. So
thousands, that's
tenths
why.
and the thousands. So this is basically, you can say 25,000. And of course, again, the way you say it, it gives you an idea what the fraction looks like. So what is the fraction of this decimal?
25 over
25 over
1,000.
1,000.
Exactly, 25 over 1,000. So when you read fractions, when you say them, instead of saying 0.025, that doesn't make much sense. But when you say 25,000, it gives you an idea what the number is like, or what is it as a fraction. And also hit 1/100ths or 3/10. So instead of saying 0.3, it's pretty much meaningless. You're just reading the numbers, but better to read it in its form, 3/10, which means 3 out of 10 of whatever it is. So we can turn fractions or decimals easily into fractions. What about this? This decimal is, if we say
Oh,
it,
0, I mean, sorry, 5/10.
5/10, which is 5 out of 10.
Mhm.
A lot of times I'll ask you to turn a decimal into a fraction like this and then reduce it, or we say simplify or reduce to the lowest terms, which basically means turn this into something smaller. So 5 over 10, we can reduce this by,
1/2.
oh,
it is
1
1
over
half.
5.
That's right.
1 5.
5 into 5, 1, 5 into 10, twice. In other words, when you say 0.5, it's half. 0.5 is half.
1.
So you reduce it to the lowest terms until you can't reduce anymore. You can reduce this because nothing goes into both. You can't reduce this. But can we reduce this fraction here?
Yes.
We can by,
Mhm.
It's going to be high. Is it
say it
one?
again. Can reduce it by,
Yes.
100. You could reduce it by 25.
we can reduce by
25.
25. Yeah, that's right.
It
So the
becomes
highest
1/40.
would become 1 over, exactly. So we can reduce it by 25 right away. If you see that 25 goes into both, that's the best way. You can do it quickly. Or you may notice that we can divide by 5. If two numbers end in 0 or 5, you know you can reduce them by 5. Again, if two numbers end in 0 or 5, or both 5s or both 0s, you know they can be divided by 5. So keep that in mind. If we divide this by 5, it will be 5. Divide 1,000 by 5 will be 200.
40.
So 200, not there yet.
Oh, sorry, I did the whole.
We just dividing by 5 for now. Then divide again by 5. So 5 by 5. 5 into 5 once. 5 into 20.
1.
And 5 into 20 would be
140.
4.
40, right? So reduce again, reduce by 5 and then reduce by 5. Or again, you could reduce right away by 25. If you see it, you can do it, that's fine. So this is the lowest term. So this is better than this fraction. So when you say 25/100ths or thousands, it means 25 over 1,000. In the simpler form is 1 over 40. So once you turn a fraction or a decimal into fraction, you can easily reduce it if possible. Here, for example, we can reduce, but we'll always reduce when possible. What else? So a lot of times, what about, let me give another example here. So let's say 0.35 or 0.25. What is this as a fraction?
2500.
100.
That's
Okay.
right. So this is 25 hundredths, which means 25 out of 100. And you can reduce this into smallest form by
Mhm.
5 or by 25. You can also reduce by 25. 25 goes into 5 once.
So it's 1/4.
Yeah, 1/4.
Exactly. Exactly. People are ahead of me. I like that.
Sorry.
Right? I like when people are engaging. Some classes can be sleepy. You put me to sleep. I talk to myself and that they rarely engage, but I love when the class is alive. Very good. So we can turn decimals into fractions, reduce them to the last terms and so on. Now let's see where do these fractions come from? Why do we have fractions? So basically, for decimals, why do we use decimals? So not every division is perfect and nice, like for example, 5 divided by 3. 5 divided by 3, 3 goes into 15 evenly 5 times. So that's good. No need for a decimal plot. You can write as 5.00, but it's not necessary. But this doesn't always go into this evenly. For example, if you have, instead of 3, you have 4. So that wouldn't divide evenly. Imagine if you're dividing $15 among 3 friends. Each friend will get exactly $5, no change, no cents. But if you're dividing 15 among 4 people, so you'll get some whole dollars and there will be some change left. That's right, there will be some change left. So each gonna get how many dollars? 4 into 15 goes 3 times, right? So each gonna get $3 and there'll be some change here. So with decimals, we don't only stop at mixed numbers. Last time we did mixed numbers, 15 by 4, 3, and 4 goes into 15 3 times. We have 4 here. And what's the remainder? If 4 goes into 15, remainder is 3, right?
3.
3. So we stopped here last time. But if you're going to get more details, we need to turn this or this into a decimal to find exactly what the value here is. And that's what decimals are for. So we need to be more precise to find this, not just say 3 out of 4. 3 out of 4 might not make a lot of sense, but when you say 3 and some whatever change here, you can be more accurate. So that's pretty much the reason why we need decimals, is to have a precise answer when the division is not perfect, when the division is not even like this. We need some change. So let's find out what this value is. So we're going to do the regular division. Okay, 15 divided by 4. So 4 goes into 15 3 times.
3 times.
That's right. 3 times 4, that's 12. And then subtract. So we have 3 and we have 0. So now, last time we stopped here when we called this a remainder. But today we're not going to stop. We're going to continue to get some precision here. So 4 does not go into 3. We want to continue with the division. So what happens now?
You're going to put a 0.
You add zeros?
You have 0 on the 3. The remainder.
Okay.
Don't you put a decimal?
And you're going to put
Exactly. That's right. So you make that remainder big enough for this. 4 doesn't go into 3, so you add a 0 here. At the same time, you need to put a decimal point here. That's how the decimal comes about. So the reason why we added is because we added a 0 that wasn't from the number. We just added the 0 to make this bigger for this. So 4, now we can do 4 into 30. How many times is that?
7 times, and it'll be
Exactly.
28.
That's right,
Yeah.
7 times 4 for 28.
28.
Subtract, you have 2 left. So again, we have a remainder. As long as you have a remainder, you can keep dividing and keep getting decimals here. So again, 4 does not go into 2. So what we do?
You put a 0 on the remainder.
Another 0.
You put a 0
That's right.
to make you
For
remainder
another
better.
0. That's right. Now we can do 4 into 20, which is,
Just 5.
5 times.
5.
that's right, 5 times 4, 20 minus, and you get 0, 0. So this is the exact value here. So when you divide this 4-way, you get 3.75, for example, cents. So if you divide the $15 among 4 people, so this is exactly how each person gets. And again, that's the reason we have decimals. Not everything, again, can be split evenly, but we can still split it equally by doing the division. And there might be some cents here, or if you're lucky, it could be something like this without any change. So a lot of times, you, instead of turning decimals into fractions, the question could be the other way around. Take a fraction, make it a decimal. If the fraction has 10 here, or 100 or 1,000, those are easy. For example, 1/10, you know, is 0.1, 3/10 is 0.3. But if you have another number here, not 10, not 100, not 1,000, so you're gonna have to do the division to find the decimal, just like we did here. Or if you have, for example, 3 out of 7, which is a fraction, what a division. We want to turn this into a decimal. So this is 3 out of 7. It means 3 divided by 7. It pretty much means the same thing. So we need to find what is the value, what is the decimal here. So again, gonna have to perform the division. So basically 3, the top always goes inside the top. The numerator goes inside the division here, even if it's smaller, it doesn't matter. Top goes here, 7, or the numerator should go here. That's the divisor. The divisor, and again, do 7 into 3. How many times does 7 go into 3? Not 3 into 7, 7 into 3.
No.
No.
0.
0, that's right. 9, which means 0 times. You're gonna put 0. So 7 into 3, 0 times. But again, we want to continue. So what do? Just like over here.
The remainder, you put in the
Yeah.
zero
The point.
Add a 0 to add a decimal.
and you put the decimal point.
That's right. That's right. Add a 0 and add a decimal next to the quotient. Then we can do now 7 into 30, which is
4 times,
Right.
and it'll be 28.
exactly. Again, we have 2 left. Then again, we need to continue. As long as you have a remainder here, you can
You put
keep
0
going.
the remainder.
Yeah, that's 0.
That's right. Put another 0 here.
One remainder.
7 into 20.
That's 2.
3 times.
2 times. 2
Only 2
times.
times. That's right. 2
Yeah,
times
put
7.
2 times.
Sorry, 2
14.
is
Subtract, you get
6.
6 left.
6.
And you keep going. That's right. You keep going. As long as you have a remainder, you can get as many digits as you want. Sometimes you may end. There's no remainder here, so that the division may end with 1 digit, maybe 2, maybe 3. But other times, sometimes it keeps going like endlessly, never ends. But when you divide, try to get at least 2 digits if possible. If possible, if
Okay.
it doesn't end with 1 or 2, so try to get at least 2, if not 3. And it keeps going here every time. 1/2 is 0.5, as we saw earlier. 1/3. What is 1/3 equal as a decimal?
0.3.
0.3, 3, 3, and it never ends. This ends here, but 1/3 is 0.3333, just like this. You keep getting the same remainder every time, and you add 0 to it, you get the same remainder. So this is one of those non-ending decimals. So that's where the decimals come from long divisions, okay? Long non-ending divisions when the division is not even. Okay, so that's basically how you turn fractions into decimals, decimals into fractions, and so on. You need to do the regular division. Now let's review all the operations with decimals: adding, subtracting, multiplying, and dividing. So we're going to divide, or basically review all those operations, starting with addition and subtraction. Again, the reason we do this is because in the class here, calculators are not allowed So we expect to do all the math manually. Okay, so whenever you do any work, make sure you show your work like this. Know how to do it manually. It's easy with a calculator, with a phone, but until you know exactly how to do it, until you're comfortable, you should be practicing it and need to know it well. Once you get to the next level, to the next math class, college algebra, in that class, you're allowed to use calculators to save time because we assume you know how to do it. You learn it in this class. In the next class, you will be able to use a calculator just to save time. So the more you do it, the better, the faster, and the more accurate you do it, the better. So practice it as much as you can. You know, you may forget stuff. Sometimes you might forget how to do some operation, even though it's simple, or maybe you did it in elementary school or primary school, but things can be forgotten. So you need to be practicing and basically refreshing your mind and memory on things. Okay, so addition and subtraction of decimals. These are pretty simple, just like adding whole numbers, except for one little trick. So let's say you want to add these and maybe say 25.4. Want to add these two. You need to align the decimal points. We need to put them together, one under the other. Not align the numbers, but the decimals. So decimal here, the other decimal. So this number has 4 here, and it has 6, not 6, 5 and 2. Okay, this is what needs to be aligned, not the numbers. Don't push the numbers to the right. You do that when you add whole numbers. Basically, we have the decimals, we have the tenths and the tenths together. You have the ones and the ones. The hundredths, this one has the hundredths, this one does not. You can put a 0 in there. And this number here doesn't have the tenths. This number has the ones, but not the tenths. You can put a 0 there just to complete the columns, so you can see everything clearly and easily, so you don't add the wrong numbers by mistake. And once you align your decimals, the rest is simple, just like adding whole numbers. Just add vertically. So you have 6. You have 11 here, so we're gonna write down 1, carry 1 to the next column, drop down the decimal point. That's right. Drop down the decimal point vertically when you get to it. Add these two, that's 7. Add these two, that's 2. Okay, it's all about aligning the decimal point. You could also add not only 2 decimals, you can add even more, 3 or 4 or 5 decimals all at the same time. If you do this, if you align all the decimal points together, you can add them all at the same time. For example, this number here, let's add it to maybe 0.003, or maybe some other number, 12.53. Okay, so we can add all these 3 together at the same time. And again, be careful to align all your decimals. So let's write the first number. So all the decimals basically should be aligned in the same column like this. So that's the first number. The other number has 0 here. Again, make sure you put everything, the ones together, the tens and so on. 0, 0, 3. The last number here, we have 2 and 1. 2 under the ones, we have 12. Then we have the tenths and the hundredths. So the tenths and the tens, the hundredths. You're gonna have some gaps. You're gonna have some empty spaces. You can always fill up those gaps with zeros. So to avoid confusing the numbers or adding the wrong numbers, you may add, whenever you see an empty space, feel free to put some zeros. It will not change the value, but you will make your operation clearer and more organized, so you can easily add it without a mistake. The rest is pretty simple. Again, just add vertically. You have 9. Again, drop the decimal point when you get to it. Add those 3 together, then 4 and 2.
So
And again, if you have to carry over something, like here, carry over to the next column or so on. So 243.939. Okay, so it should be accurate. Again, when you do this, make sure you can do this quickly and also accurately. Don't spend too much time on it. And you may use the calculator afterwards just to check. Let's say you added a bunch of numbers or you multiplied or divided. You can just check with the calculator, but not use it to get your answer. Make sure you show all this stuff on the side when you do any math. Okay, so that's addition, just addition. It's no big deal. Subtraction can also be just as simple, sometimes a little tricky. We're going to see an example of that, but let's start with something simple for now. Maybe something like this. And from this, we want to subtract maybe 3. And what else? 5, something like this. So again, make sure you align your decimals here and here, and 3 here, 5, the ones, the tens. Again, you can always put some zeros here. We have 0 here, 0. And then subtract normally, just like you would do with whole numbers. Subtract vertically. So that's 4.
2.
7 take away 5, that's 2. Bring down the decimal.
2.
2.
Right?
And then 2 again.
And 2. And that's it. That's just as simple. Right? So pretty simple. Other times you may have to do some borrowing. Let's say you want to subtract something like this. From that, you want to subtract maybe 9 point, let's say 4, maybe 3 here. So that's a lot different than this. So again, let's align those numbers.
Can I put the 0?
Gonna align the decimals here, and we have 9 here, 4 and 3. It's very important. Again, aligning decimals is very important. Just like when you add your money, you want to add the dollars together and the change or the quarters, whatever, together. So you can't mix them up. This will give you the whole part. This will give you the decimal part or the change. Again, feel free to put zeros in the empty spaces. Okay, so now watch out, everybody here. We have a situation. So we want to do 0 minus 3, which we can't do. We can't subtract 3 from nothing.
That would be 10.
So you borrow from
10?
the 8.
That's right. We're going to borrow 1 from here to make this one bigger. We're going to borrow 1 from 8, turns
It's
into 7.
1.37.
Okay, so the one we borrow from here, goes here next to this number. So we consider this now to be a 10 or whatever number is here. For example, if you have 2 here, would be a 12 and so on. So we can now do this, take away this. So that's 7. Then 7 minus 4, no problem. No need to borrow 7 minus 4, that's 3. Bring the decimal down. Then again, we have a situation. We want to do 6 minus 9. We
So
can.
we're 1.
So we're going to borrow
You
from this
borrow
one.
that 1.
That's right. Subtract 1 from it, turns into 0. And the one we borrowed goes here next to the 6. So now we have a 16. We need to do 16, take away 9. What is 16 take away 9?
8.
7.
7. That's right. Finally, we have 0 left here. 0 take away 0 is 0. Okay, so be careful with your subtractions, especially when you have to borrow. And again, this may seem easy, but again, don't assume so until you do it yourself and you do it, like I said, quickly and accurately. Be careful. You're going to get the exact value, you know, when you check with the calculator, should be accurate. Okay, that's a little review of addition and subtraction. You'll see more of these practice problems in the homework. Any questions about the addition and subtraction, everybody, before we go to the multiplication and division? Please let me know, everyone, if you have any questions at any moment. Feel free to ask questions, answer questions. All right, so let's move on to reviewing the multiplication and division, which is different from here. It's a different story here. So multiply and division of decimals. When you divide decimals, let's say 1.8, divide, let's say 0.6. Can someone give us the answer? Not by not doing any math, just by looking at it. Can you guys figure out what the answer is? It can be done actually in a few seconds if you know a trick. 1.8 divided by 0.6. No calculators. Let's look at it.
1.2.
Not 1.2.
1.2. No.
No, not 1.2. You
Oh,
can
we're
already
doing
see the
division.
answer.
Sorry.
Division, yeah.
Yeah, division.
So just look at it again. Try not to use a calculator or anything. Just look at it. Look at the decimals. See if you can figure something out.
0.3.
0.3, not quite. Pretty close, but not 0.3.
This is 0.2.
3.
Well, let me show you. That's right. Would be 3. So very simple. When you have something like this, basically just move that decimal. Get rid of it. If you move the decimal here, this turns into what?
18.
18. That's right. We move this once. We move this one once as well. This turns into.
Oh, that's 6.
Okay.
Turn them into
and-
whole numbers.
So
and
then it's 18
divide.
divided by 6, which is 3. Makes sense.
Exactly. Okay, so next time you see something like this, it's not always possible, but if one goes into the other, so you can do this literally in a second or two. But if you have 7, here, it might not be as simple. You will still have to do the division. Okay, so when you divide decimals, move them, get rid of them, turn everything into whole numbers, and dividing whole numbers should be easier and more familiar, just like we did earlier here. We do the regular long division. Let's see another one when it's not as easy, not as simple. For example, if you have 1.7, we want to divide this by maybe 0.5. So you may get an idea, but probably not the exact answer. So you could get at least how many times it goes into it. Just if you move this, you can at least tell how many times this number goes into this, at least the whole part, and then you will figure out the decimal part later. So how many times do you think this goes into this by doing this stuff here?
3
7.
times.
3 times, that's right. This is
34.
technically,
3.
this is basically 17. This is basically 5. So you look at it, you say, oh, 5 into 17, so that's 3 times. Okay, so that's 3 times. Then to find the rest, we'll have to do the division. So basically that's 17 divided by 5. And let's figure that out. Again, it should be simple to do the division. Okay, so 5, again, we set into 17, that's 3 times. 3 times 15, 3 times 5, that's 15. Take away. The remainder is 2.
2.
We said, okay, that's 2. All right, so now that's a remainder. So we can
So
continue.
we add a 0
to
and
get-
a decimal.
Exactly. So we're gonna add a 0 here because first 5 does not go into 2. Gonna make this bigger. Same time, add a decimal number here.
Okay.
And now we can do this into this. How many times?
4.
4.
Exactly 5 times, evenly. No remainder left. 4 times 5 is 20. That's it. So this ends right here. Some of them you keep going, but this one ends exactly like this with 1 digit. So the value here is 3.4. Again, sometimes it could be pretty quick. If not, you can always do the division. But at least least you can get the whole parts by doing by moving the decimals. You can at least get an idea of 5 into this. You say, oh, that goes 3 times, so the answer would be 3 point something, and then you do the division or something to find the other part. So that's the first thing you want to do, okay? When you have decimals, turn them into whole numbers by moving the decimal to the end of the number. From there should be easy, a regular long division like this one. Okay, let's look at another one. It'll be a little bit different this time. Let's say 12 or 1.23. Let's divide this maybe by 1.1, for example. All right, so what is it again that we need to do first, everybody?
I'll make it into a whole number.
Make everything into whole numbers. How exactly do we do that? What needs to be moved? How many times?
Decimal.
That
The first
twice.
decimal
Twice.
twice.
123 divided by 11.
So here we're going to move this twice. What about this?
One.
One.
Okay, so the trick is if you move one of the decimals, for example, 2 times or 5 times, whatever, you have to move
You
the
have
other
to
one
say,
also. That's right. Also, same number of times. So you don't want to change the ratio. You don't want to change the value of the whole thing because we move both. It's like adding, it's like a fraction. When you multiply a fraction, as we saw before, we multiply by the same number on both sides. That way you can keep this value the same. You don't want to change the ratio here. Same thing here, this division. If you move twice, we're going to move twice here. But here you may say, oh, I only have 1 digit, so how do I move this twice? So what do you think we need to do?
Are you gonna add a 0?
That's
Yeah.
right. Always feel free to add zeros.
There's a
That's right. So whenever you have decimals, feel free to add as many zeros as you want to the end here or to the front. It will not change the number. For example, if you have 2.5, that is the same as this. It's still the same number. You can add as many zeros as you need before or after the to the right, to the left, it will still be the same. Here, we move twice. We need to move this twice also, so we're gonna need to move once. And that brings us to the whole numbers, 123 and
110.
that's right, 110. And let's go ahead and do this division. So 123, 110. 110 into 123.
One
That's,
time.
that's right,
One.
just one time. 1 times 110. Write it down here. Subtract.
13.
That's right. So 3, 1, 0. But again, we're not doing mixed numbers. We're doing decimals. So we need to continue. So 110 does not go into 130.
You add
And
that
again,
zero.
add a 0 at the same time, add a decimal point. And what else?
110 goes into 130 one time.
That's right. Let's into this once, times this by 1, will be 110. Subtract, we have 20 left, right?
Mhm.
20 left. Let's get another digit. So 110 does not go into 200. So what do we do?
Put a 0 on the remainder.
That's
Continue.
right. Another 0.
Yeah.
So that's 1, 1. Then you subtract and so on. So at least 2 digits. This looks like it's going to keep going,
Oh, no.
but at least 2 digits. So the answer here to this decimal is 110 because we're dealing with decimals. The answer should also be a decimal, not just stop at a mixed number with a remainder. So precision. So decimals give you more precision, more accurate results. You can even get more, depending on what field you're working with. For example, if you're working with money, you just need two digits after the decimal, 4 cents. Cents, they go from 1 to 99 before they turn into $1. Other fields, there are actually some in physics and signs. Sometimes they require like 23 decimals or maybe more, depending how precise you're trying to be. So it could be a very long decimal here. So depending on the field, if you're measuring, for example, the mass of an atom, you're gonna need many decimals in the like more than 20. But if you just measuring something simple like a weight or something, you may just need 2 decimals. Or if you're dealing with money, 2 decimals are enough. So this is basically how you you divide decimals. First thing, turn them into whole numbers, then do your regular divisions. So make sure you are familiar with the divisions, regular long divisions, multiplications, all those basic operations.
Can I ask a question?
Sure.
I used the calculator, right? And I got 1.23.
For the last one?
Yeah.
Okay, there might be a mistake somewhere. So let's double check. So we said this goes 1, so we subtracted. This is 3, 130. Then we said again once, 1 into 110. So we have 0, we have 2, 0.
No mistake. No mistake. It's good. Actually,
If you divide them as decimals, it comes out the
it's
same.
good. It's good. It's the same.
But if you divide it by whole numbers, it's not the same.
Okay, let me try because
Okay, I think, okay, I think I know what the problem is. Let me just double check.
Oh no, actually they both come out the same. They both come
111,
out
and
as
the other one.
So when I
one decimal point 11,
No, 111. 111. The thing is, if you continue,
the zero.
if you continue dividing, you'll get more numbers.
It's the same thing.
Yeah, it's the same thing. But if you continue dividing, you'll get more numbers here. So here we stopped at these two. If you continue dividing, you may get many more digits, and then you round
oh,
the digits to the nearest whatever 10th or 100th and so on. But it's about the same. At least the first 2 digits are the same. So again, 2 digits should be enough. 2 decimals at least should be enough for now. That's the division. Now let's do some of the multiplications. Let's say you want to multiply maybe 1 to 1.25 by maybe 2.3. Okay, so the thing with division, I mean, the division, we get rid of the decimals. Here, when you multiply, you don't actually need to align the decimals, unlike addition and subtraction. No need to align the decimals. So decimal is here, also here. So you do not need to align it when you multiply. You only need to align it here when you add or subtract, like we did here. All these problems. Please mute your mic, whoever has background noise. Please mute your mic. So, like I said, no need to align your decimals when you multiply. We will deal with the decimal at the end. So multiply now just like you would multiply whole numbers. Put the decimal there, but don't worry about it. Just ignore it for now. So we're going to take 3, multiply by all these. Then we're going to move to 2 and also multiply it by all these. So 3 times 5 is 15. Going to write 5, carry the 1. Then 3 times 2 plus the 1. That's 7. And then again, so cross out this carry over. 3 times 1 is 3. Okay, we're done with the first one. We're going to move on to the second and do the same. But when you move from one digit to the other, what needs to be done here?
The 0
Add
into
a
the
decimal.
5.
That's right. So the moment you move for the first time, gotta put a
Mhm.
0 first. Just put a 0 there first before you start multiplying. If you
Oh,
move
yeah.
another time, then you will have to put 2 zeros and so on. So for the first time, put a 0, then multiply. So 2 times 5, that's 10. You gotta write 0, carry the 1 to the next column. That's right. 2 times 2, plus the carryover,
5.
5.
11.
that's 5. And
Oh,
then
shit.
2 times 1, that's 2.
2.
That's right. Now we just, after multiplying, we need to add everything vertically, just like adding whole numbers. So vertically add everything. That's 5, 7.
8 and 2.
2.
That's right. So
And
after
then
you're
3
done,
decimal places.
how many decimal places?
3.
3. That's right. So after you multiply and add, that's when you need to place the decimal somewhere here. So based on how many decimals you have. So where exactly does the decimal go? Between what numbers?
Between
2 and
7 and 7. Between 8 and 7.
Not between 8 and 7.
Between
and
2 and 8.
2 and 8.
Mhm.
That's right. 3 decimals. We have 1, 2, and 3. Okay, so we count all the decimals to the right. So we have 1, 2, and 3. So you're going to count 3 numbers. 1, 2, and 3. Put it after the third. Unlike addition or subtraction, we align them and you drop it down. This is not the same thing. You have to count all the decimals. Again, 1, 2, 3. So 1, 2, 3. And the exact value should be this. And when you check with the calculator, you should get the exact same value. If not, double check everything for steps. And again, the key thing here is to do it quickly and accurately. So again, the more you practice it, the easier it gets, the more comfortable you get with it. All right, so here we had 2 digits here. That's why we have 2 lines. You may have more than 2 lines. If you have 3 digits here, if you have, for example, another number, maybe 6 here, then you would have another line here. So let's do another one this time, maybe with 3 digits here and 3 digits, and see how to get 3 lines for each one. So maybe 2, 1, 3. Let's times this by some other number. Maybe 11 and 5. Again, don't worry about aligning decimals when you multiply. Just write your numbers. Just write them, push them to the right, just like you would do with whole numbers. Push everything to the right. No need to align the decimals. They may end up aligned coincidentally, but that's not a problem. But we don't care about aligning them when we multiply. So we're going to put this one here. This one is here. So again, they're not aligned. They don't need you. Okay, this is going to be a longer one. Okay, watch out, everybody. Watch closely here. Then take the 5, multiply by all, then go to the 1, multiply by all, move to the 1 again, multiply by all. So we're going to have 3 lines of multiplication, 3 of these. So 5 times 3, that's 15. 5, carry the 1 to the next column. 5 times 1 plus 1, that's 6. That's right. Remove this or cross this out so it doesn't confuse you. 5 times 2, that's 10. So now we're going to move for the first time from 5 to 1. We're going to put a 0 here. For the first time, we put 1 0. For the second time, 2 zeros and so on. So we have 1 times 3, that's 3. 1 times 1, that's 1. 1 times 2, that's 2. Good. So we're done with the 1. We're going to move now for the second time. We're going to move to this digit. So what do we do here?
You put 2 0.
2 0.
2 0.
Exactly. So 1, 2, and then multiply again. 1 by 3 is 3. 1 by 1 is
1 and
by
2.
2. That's right. So we have 3 lines. So I'm going to add all these together vertically before we see what to do with the decimal. So we have 5 here. Right.
9.
9.
4.
That's right. 4.
4.
4 again. That's right. And so what exactly do we place the decimal between what numbers?
After
The 4
24.
and the 4.
4 and 9.
Four, that's
Oh,
right.
four
Between
and
the
four.
4 and 4. I
Correct.
count 3 numbers. We have 1, we have 2, we have 3. So 1, 2, and 3.
2, 3.
3 digits. And that's our answer for that multiplication. This is, again, shouldn't be that hard. At the same time, you need to be careful with it, okay? Because a lot of stuff going on here. You can easily like misplace a number or multiply the wrong numbers or make a mistake. But again, you can always check with your calculator and make sure you get everything accurately. Okay, so that was a little review of all the operations with decimals and divisions and so on. Any questions, everybody, about any of these operations so far?
I don't have any question.
Everybody else, please let me know if you have any questions. So again, get familiar with these. Do as much as you can. You will see them in the homework. Trust me, the more you do it, better. It actually makes you think faster also. It trains your brain to think faster. So maybe you haven't done these in a while, but trust me, this trains your brain and you become sharper, not only in math, in other things. So you try to do, your brain gets basically trained to think faster and do the math faster.
Professor, sorry to interrupt you. The last exercise that we did, why we put like the 11.5, like, how can I say? Because I was taught differently, but I think in this case it's.
You said, why do we put 11.5?
Like
What do you-
behind the, how can I say that? I'm trying to find the correct term.
What's the, do you have another way of writing it? What is
I was 11, I usually like choose like the high number, which is 11.5, and then under that 2.13.
Well, it's not necessary. It's not necessary. You may choose the number that has more digits. For example, 5, 7, 8, 4. And if you're multiplying it by another number, let's say maybe 3.7, the one with more digit, not necessarily the higher one. For example, if you have 8.7 and you have these, you want to multiply them, you would put this one first, not because it's bigger, it's actually smaller. This is just 5, this is 8. You would put the one that has more numbers first, followed by the one that has less numbers. But you can tell here that the result will be the same either way. Not because of if it's bigger or higher, but the one with more digits. Does that make sense? The one with more numbers goes first. But either way, the result should be the same.
Okay, thank you.
All right. But when it comes to subtraction, you do it, of course, we start with the higher one. With subtraction, you have to start with the higher one minus this. I mean, in the way it's set up. If it's set up like this, we have to do it in this order. This minus this. Division or addition doesn't matter which one you start from. Even with this one, you could start with, can reverse the numbers, it will be the same. Multiplication also, you could write this one first. It will not change the result. Okay, any other questions, everybody?
Yes, the first part, I think I missed some part on the first exercise.
Which one?
Can you scroll up, please?
The beginning?
The beginning, yes.
Okay.
The where it says definition, I think because I got late.
Okay, so this is just basically to remember the names of each place value. Each one has a name. So the first one is the tens, the hundreds, the thousands, and so on. Because a lot of time the question would say round to the nearest tenth or the nearest hundredth or this. So you should be able to locate the numbers here. For example, if you have a something like this. So I would say, which digit is in the, for example, in the hundredths? Which digit is in the hundredths position? Everybody, which digit here is in the hundredths position?
5.
The 2.
5.
Two. Two is in the
why
hundredths.
did I
What
say-
digit is in the tenths?
7.
That's right. This is the
Yeah,
tenth. So the first one is the tenth. And then what digit is in the 10,000s?
6.
6.
That's right. 10,000s. And this is the thousands.
Thousands.
So that's basically what you need to remember. A lot of times you'll be asked to name a certain digit or round to the nearest something. We'll talk about that in the future. I think we're going to see those time in the future. Okay, so that's basically your operations. Again, practice this more, check for yourself, check with the calculator to see if you got it right. Now let's see the relationship between decimals and percents. Decimals and percents. Number 4. Decimals and percents kind of go hand in hand. They're almost the same thing. We can switch back and forth between them easily. First, let's take an example out of a percent, 15 or 17%. What does that mean when you hear 17%?
17 out of a whole. So a percent out of a whole.
17
Out of 100?
Out of 100. That's right, 17%. So percent literally means per 100. So this is 17 per 100, or in other words, 17 out of 100. So for example, 17% of the people were absent, for example. That means like 17 out of every 100 people didn't show up. So that's the percent. We can turn it easily into a fraction with 100. The percent always has 100 here. If you think of this as we did earlier when we were talking about decimals and percents, what is 17 out of 100 or 17 hundredths? This is 17 hundredths. What would this be as a decimal? If you think about this.
0.017.
0.17.
0.1.
0.17. That's right, 0.17. So 17 hundredths. This is 17 hundredths, the tenths, the hundredths. Another way of looking at it is whenever you divide anything by 100, you move the decimal to the left twice. If you don't see the decimal is always invisible here at the end of a number. If you don't see it in a number here, you see it clearly. If you divide this by 100, you move it to the left twice. If you don't see a decimal in a number, and you want to divide by 100, this is the invisible number. Just move it to the left twice. That's how you end up like this. Ends up like this, 0.17 or 0.17. Okay, you just move your decimal to the end. So whenever you divide in anything by 10, by 100, by 1,000, no need to do the long division like we did earlier. Save time. Just move this twice to the left. Don't spend 5 minutes doing it manually. You just need to move the decimal. Unless you're dividing by something different, for example, 126 or something, then you'd have to do the division like we did earlier. But for divisions with tens, hundreds, and so on, just move it to the right, to the left twice, to the left. Okay, so as you can see, we can convert easily between percents, fractions, and what else?
Decimal.
And decimals easily, simply by doing some tricks and moving the decimals and basically applying the concepts of fraction, the decimals that we learned earlier. When you read the decimals in their form, in their standard form, gives you an idea what the fraction looks like, what the percentage is, but they make more sense. So we started from here. We were able to find the other two. Now let's start from maybe here with a fraction and try to figure out the other two. Doesn't matter which one you find first. Maybe the one you think is easier to find. Maybe this one, maybe that one. So what do you think? We need the percent, we need the decimal of this fraction. Maybe the percent would be easy to find first. 6 out of 100. What does that mean?
6%.
6%. So anything out of 100 just means that thing, percent, anything. Immediately check that, write the percentage sign to it, or take this, play it over 100. And
0.06. 0.06.
exactly.
0.6.
So this is basically 6 out of 100 or 6 hundredths. 6 hundredths. Not here in the tenths. Don't make this mistake. It's not 6 tenths. It's 6 hundredths. 6 out of 100. So it's going to be like this. 6 hundredths. So be careful when you have only one digit here. So you got to move the decimal twice. Again, speaking of moving the decimal, so the decimal is invisible here. You want to move it twice to the left to go here. So you add a 0, so you move this here, so you get 0.06 or 0.6. You can also start from here and find the other two. Let's see, maybe. Okay, so let's start from here now. Which one do you think is you want to find first, or which one is easy to find right away? It doesn't matter. You can start with either one.
Égal à 37%.
37%.
37%.
That's right. That's fine. You can do that as well. So basically, when you have, what you can say, how do you read this in decimal form? What is the actual decimal form?
0.37.
30, say it again.
3700.
3,700. That gives you an idea of the fraction. What is the fraction?
37 over 100.
Over 100. And this basically gives you the percent. That's the percent. So this would be
37%.
37%. Exactly. Or again, that's fine if you find the percentage first. So here's a trick if you want to find the percentage first. So we said we go from here to here. We basically move the decimal. By the way, you don't have to go through this first. You can change between decimals and percent right away. You don't have to go through this step. For example, if you want to go from this directly to the percent, just take that, move it to the left twice. Take the decimal, move it to the left twice.
And 1 and 1. So.
And that's if you want to go from here to here. But if you want to go backwards, you move this
To your right.
to the right. So if you want to go from decimal to percent, move this twice. The other way, so move either to the left or to the right. And it has to be twice, not just once. For example, this one, let's say ignore this fraction. How do we go from this directly to this? How many times do we move the decimal again?
We're going to be moving it to the left.
That's right, twice, not just once. It has to be moved twice. So you can add a 0, you move it here. This is 0.06 or 0.6. And if you have this, you want to go to the percent again, you must move twice. If you need a digit, you can add a digit next to it, a 0, but you have to move it twice. If you move this here, you get 6%. And that's basically how easy it is to go back and forth between decimals and percents. A lot of times, this is what you're going to need the most. This to this directly, percent to decimals. That's what you're going to need the most. So again, you don't have to do it first through division, just move the decimal and you get this. And if you have the fraction, if it has 100, that's your percent. If you have 100 here, that's your percent, 17%, 6%, 37%. What if you don't have 100 here? Let's say, what if you have 5, for example, and 1 here? Does this make it 1%? Can we call this a percent? We can't, because this is not 100, so we can't say 1%. Unlike this, we have 100, 37%, 6%, and so on. Since we don't have 100 here, so we can't figure out the percentage yet. Maybe I'm actually make this one too. Actually, not that. Let me change the whole thing to something we've seen earlier, maybe this. So forget about the percent for now. We don't have 100 here, so we can't say this is a percent. Maybe this time we could find this first. And from that, once you have the percent, I mean, the decimal, you can just move it to the right. What is the percent of 1/2? What's the, I mean, not percent. What is the decimal?
0.5.
0.5.
That's right, 0.5 or 0.5. And now let's see how to turn this into a decimal into a percent. So what do we do to the decimal here to move it, to turn this into a percent?
0.50. If
Is
you
it?
put in, if you want to put in percent, it will be 0.05%. It will be
No,
it will be,
which way
Well,
do
you
we
move the
move?
decimal to the right and
oh,
it'll
To the
okay.
right.
It will be,
Right,
Yeah.
we need to move it to the right twice.
mhm.
But here we only have one digit. So what do you do?
add a
Add a
zero.
zero.
Put that
Add a
close.
zero. Exactly. Make sure you move twice, either to the right here or to the left. If you need some digits, put zero. So what is this as a percent? You move this.
50%.
50. That's right, would be 50%. So usually, if you have one of these, if you have one of these, you can find the other two. And maybe sometimes one of them can be easier to find than the other. So feel free to find either one first. The one you think is easier for you to find, that's fine. So bottom line, if you have one, you can find the other two easily. Most of the time without doing any math, just by doing the decimal. Maybe if you have division here, sometimes you may have to divide. For example, if you have 3/7, so you will have to divide first, as we did earlier, make it a decimal. Once you have a decimal, move the decimal to the right twice. But other than that, if you have 100, you have decimals here, either move to the right or to the left, easily without having to do any math. Okay, and this is just a little introduction here to percents. We will have another class on percents in details, all the formulas, we're going to use equations and so on. So this is just a quick introduction just to see the relationship between decimals and percents, how to switch back and forth easily with these shortcuts that I showed you. But a few classes from now, we're going to discuss the percents in more details with all the formulas and finding the numbers and so on. For now, maybe just remember this. For example, a lot of times the question would say, what's 17% of some number? I don't know, 23. So to find a percentage of anything, percentage of any number, you take the percent, make it a decimal. What is this? Okay.
0.17.
That's right. Make it a decimal, simply move twice, and then just multiply it by the number.
Mhm.
That's it. This is what we did earlier. Multiply, you get your value. So what if you have, so what's 17%? What's 8% of, I don't know, 15? How do you find this?
Make the 8% out of to a decimal.
Okay, so what is 8 as a decimal? 8% as a decimal?
0.8.
0.8.
0.8.
Not 0.8. Not 0.8.
It's
You need to
0.8?
move it twice.
Oh, 0.08.
I mean, yeah, 0.08. Sorry.
That's right. So you got to move this twice. So it's 0.08 or 0.08 times it by 15. You'll find the value. So that's just a shortcut for now, just to find this quickly. But later we're gonna learn a formula and make these equations and so on. So turn percent into a decimal, multiply by the number. That's why I told you earlier, most of the time you will need to turn the percent into a decimal to use it. Later we're going to see how to even use this into equations, turn the percent into fractions, put them in equations and solve all basically percentage related problems. Okay, everyone, any questions about this last part here, the percents? Right. Again, we are coming back to this in detail. For now, just get an idea. Don't worry too much about the
Professor,
percent for now.
sorry, the 50%, the last one, I didn't get it. What it says that 1/2.
So first you divide this, right? You divide. You turn this into a decimal. The decimal here is 0.5 or 0.50. Then to make this a percent, move it twice, move the decimal twice to the right. So when you move this to the right, you got 50%. Okay, so if you have, for example, 3 out of 4,
Okay.
what is 3 out of 4 as a decimal? You have 3 out of 4 here. 3 out of 4 as a decimal is 0.75. If you do the division like we did earlier, so that's the decimal. What is a percent? How do you turn this into a percent?
So it would be 75%.
That's right. You just move this,
You
and
just
you
move
have
0 to
so you have a percent. But first, get the decimal. If you don't have 100 here, divide this first into decimal, then move it to the right twice.
Okay.
All right. Any other questions, everybody? Let me know if you have any other questions, everybody, before we